Hi, this is Roland McPherson, Real Turf Tech, keeping it real. We're going to talk about height to cut gauges. As always, 1 mil means 1/1000th of an inch. Now there are at least 5 brands of height to cut gauges out there now. At least 2 of those brands have a flat bottom catch. This is the catch. You need to be aware of the bottom of it. Some of them are flat, perpendicular to the stem. Some of them are tapered. This is a very popular brand called the Frankenstein. I put this gauge together from a bunch of parts that were kicking around the shop. It's an Accu Products bar. It's an R&R dial indicator. It's got the magnet and the catch. Who knows what brand of gauge that came off of. So you want a catch that's tapered on the bottom, and the taper needs to be greater. The angle of the taper needs to be greater than the top face angle of your bed knife, both when the bed knife is installed and at the end of the life of that bed knife. So to get an idea of what that angle is that you have, you're gonna find the attitude, the angle of the bottom of the bed knife in relation to the ground. So on a Toro Greensmore, that's usually around 5 degrees or so. On a John Deere QA 5, it's usually about 7 to 9 degrees. So what you want to know is the angle of the top face in relation to the ground, or your height of cut gauge. So let's say we've got a Toro with a 5-degree attitude, and the micro cut standard length Toro OEM bed knife has a top face of 3 degrees. So that means that this top face is actually pointed down. The front cutting point of the top face is lower than the back of the top face. And in this scenario, it's 2 degrees from the ground, or the height of cut gauge. So if we project that over here, this is what we have. I'm going to call that negative 2 degrees. So here we have a flat bottom catch. It's not measuring the height of cut. The height of cut would be the distance from the cut point to the ground, or the height of cut gauge bar. So here, this flat catch is measuring the distance from a point behind the cut point up above on the top face to the ground. So your height of cut is actually lower than what this gauge is reading. Now, let's say we have a John Deere QA5 Greensmore with a attitude angle of 9 degrees, and let's say that we have one of those aftermarket bed knives, ultra thin, with a top face of 0 degrees. Those are the ones that are meant to be used when mowing below 100 or below 80. That means, so we would have 9 degrees here, 0 degrees here. So this angle would be 9 degrees, or as I call it, -9 degrees. Okay, so let's imagine that this is the angle that's created with a flat bottom catch. And so this angle would be 9 degrees. Let's say the length of the catch is 100 mil. That means that this distance would be 15 mil. So your gauge would be reading 15 mil higher than your actual height to cut. So your gauge could read 80 and your actual height to cut would be 65. So you're going to run into 3 different type of catches. Here's one with a flat bottom. Here's one that I've also seen. It's pretty common. It's got a taper out here, but over here next to the base of the stem, it's flat. And here we have a catch where the taper extends from the stem to the outer edge entirely. So the reason that you will run into this is because these catches are not made for height of cut gauges. This catch would be the type that would be made for a height of cut gauge. Now, I modified this catch. This one was flat on the bottom, and it's still flat on the bottom on this side for demonstration purposes. And I basically filed a taper of about 10 degrees on this side, and I did that with a diamond stone. I got a cheap diamond stone, about 15 bucks, and in order to get the edge of the stone up against the stem to get this, I had to whittle away the plastic edge here, and that allowed me to get this right up against the stem. And it's pretty crude method of putting a taper on a catch, but it worked out fine. So this, I filed that taper until this gauge read I was able to calibrate it both with a known distance that was parallel, and also one that was tapered, and I'll explain that in a different video. So another thing to be aware of with these gauges is that they bend or deflect. So often a mechanic will hold it up to the cutting unit and push on it hard enough to bend it. They bend pretty easily, and you can tell when you hold it up to a cutting unit. If you pay attention and you're holding it up there and you push on it, then you'll see the reading change by, you know, maybe 3 to 4 mil as you're pushing on it. That might not be a problem if you can measure that amount of deflection and if it's consistent. And the way that amount of deflection can be consistent is if you have a hands-free mechanism like this one does. This one has the magnet, and in the other video you'll see that this magnet is strong enough to hold this gauge up to the bottom of the cutting unit, and while it does that, it actually bends this bar, but I was able to measure that. It bends it by 2 mil. So since I know that, as long as I'm using this hands-free mechanism and I know that my reading is 2 mil off, then that's a good option, because I know that my reading is going to be consistent. Alright, I'm going to go over the way that I used to check and calibrate a gauge. So first I would unscrew this or remove this catch, and then I would lay this bar on a precision surface plate, and then I would slip some feeler gauges underneath it and measure how not flat the bar was, because most of them are not flat. Then I would take a block of a known thickness and slip it under here and then calibrate. You know, this is a 25 mil shim. Then I would calibrate to read 25. Alright, that one's reading 26 right now. There are a couple of problems with checking and calibrating a gauge that way. Number one, if the bar is not flat, then that's not a good way to calibrate it, because you're only calibrating this area right here underneath the catch. So if the bar is not flat, then you're not gonna get the correct reading when this is up against a cutting unit. The other thing I noticed was this collar right here on many of the gauges is protruding up higher than the surface of this bar, so that's going to cause a problem with calibration also. So some stuff to be aware of. All of these issues that I brought up were addressed when I came up with the height of cut calibration plate, which will be in another video.